In this session, I'll be talking about comparison tests when the response is continuous. So at the end of this module, be able to compare the mean and variance of two continuous data populations. You'll also be able to understand the implications of alpha and beta. Next thing you'll be able to do would be able to know when to create and how to execute a paired comparison test. For continuous response key process output variable, know how to determine if an improvement has actually been made to a process upon completing a project that was to improve the process. So where we at in the overall roadmap is under the analyze phase. Analyze phase has several deliverables. There's tools associated with them. So we're going to be focused on some of the how-tos of creating a confidence interval and a hypothesis test for a given situation. So if we drill down on the analyze roadmap, then we would get this particular swim lane that's shown below. Now, where we're going to be focusing today on is the step number 7.6, where it's hypothesis to gain insight. Now, if you drill down on that, then what you got is a decision tree. So the circled items on the right-hand side is where I'll be focusing the efforts on this particular session. Notice what we have here on 7.6.0, we're doing a hypothesis testing. We've got two or more of the variables. That goes down to 7.6.22. Output is continuous. And then we have, if we follow the lower tree, we look at input as categorical. So we could have like machines and so on. And then we're looking at mean equality, 7.6.32. And we're going to focus on 7.6.33, a two-sample test. Now we can also go in the upper tree branch and we see two-sample comparison of an F test. So those are the focus areas for this particular session. So we start with the 30,000 foot level chart. So as we see in this particular chart, we got a 17% non-conformance. So let's say that we want to actually improve this chart. So what do? Well, you can capture data from the recent region stability to go in and determine, run various hypothesis tests. That can give you insight to what you might do differently. So again, it's from a recent region of stability. That could be 3 days, 3 months, or 3 years. With wisdom of the organization, say, thoughts that you might do to make improvements. The other thing it also helps with is a quantification of the benefits from a 30,000 foot level metric where the individual's chart transitions to enhanced level of performance. So we can have a quantification of that benefit. So what we really have here is a 30,000 foot level chart, and then it creates a pool for a process improvement project. And if you did a good job, that changed to a new level, and then it shows that we improved our process, and hopefully it has a bottom line benefit to it. So that's what we're really trying to accomplish here. We're trying to see what we could do to improve the process, and we're going to be running hypothesis tests. Now let's consider we had two suppliers. What does that mean? Well, if the mean value of each of the suppliers is different, then that would affect our 30,000 foot level metric. And so we'd like to understand that, and if that's the case, then that would give us insight to what we might do to improve. Another way of looking at this is taking the mean response from a 30,000 foot level individual's chart, and we can quantify the difference here and actually be able to assign a confidence interval when we take the data from the recent region stability and enter it into this methodology of comparison tests. So we can look at both the mean and standard deviation between the samples to determine if the difference is large enough to be considered statistically significant. If the comparison of the means is robust to the shape of the underlying distribution not being normal, however, that's not true of the standard deviation. You can use non-parametric statistical comparisons when comparing standard deviation if the population is not normally distributed. So in this module, we learn the mean and variance comparison of two continuous data populations where there's an understanding of alpha and beta. Compared comparison testing, application, and execution. Let me talk about that a moment here. Let's consider we've got a tester and we've got 14 different parts that we want to test. And it's got a response to this tester. So we put each product into each of the testers. And now we look at the difference between the testers. If they were exactly the same, the response would be 0. This would be an example of a paired comparison test that you might do. So before you can do a paired comparison test, you really have to have a certain type of situation that I just described there, where the transaction or whatever you're looking at goes through both of the processes. So we also talked about continuous response, key process output variability, determine whether an improvement has been made to a process upon completion of a project, and we also can get a confidence interval on the amount of improvement that we made through the project.